Sir Christopher Monckton is going to be presenting on why extreme weather was wrongly expected. And he'll have some interesting facts for you. Take it away, Christopher.
You see me on the program as James Taylor. No greater honor could be conferred upon James Taylor. In fact, the truth is that no greater honor could be conferred upon me than to stand in James's name. Having had a horrific accident only a few months ago, James has bravely proceeded with this conference, has come here, has chaired it with his usual steady hand and kindly wit. Can we give him our appreciation for that? Now, I'm here to talk about wildfires and tornadoes, and very kindly, because I was called in at rather the last moment, Anthony sent me some slides, and I had unfortunately mistakenly thought that those were the subject that he was going to talk about and that I should therefore avoid, so I haven't included those slides. So I must apologize most abjectly to him for my stupidity, but I can tell you all about wildfires and tornadoes. They're not a problem. And that's the end of my talk. What I thought I would do is to say why it was that the climatologists thought that there might be more extreme weather. Now, I actually asked Sir John Horton this question. He was the chairman of the IPCC for its 1990 report, and in 2007, I got in touch with him and I said, I can understand that if you have a doubling of the CO2 in the atmosphere or the warming from all greenhouse gases made by man over the 21st century, you would expect 1 degree, roughly, 1.2 maybe, of direct warming. But how do you parlay that up to 3 or 4 or 5? And he said, well, this is feedback response, you see, because of extra water vapor in the atmosphere as it warms. So I said, fine, but why do you think that it's that big? I mean, this is an essentially thermostatic system. So why so big a feedback response? That doesn't seem a priori to be very likely. And he said, well, we have to go back to 1850 before we started messing around with things. And he said then the total natural greenhouse effect was 28 Kelvin. And the direct warming from all the non-water vapor greenhouse gases at that time was 8 Kelvin. 28 over 8 is 3.5. So if you have about 1 to 1.2 Kelvin of direct warming, you multiply by 3.5 and you get 3 or 4 Kelvin, and that's why we think that's how much warming there's going to be. But you see, they screwed up. They got it wrong. And if we look at this slide, this shows the IPCC's current projection of 3 to 5 Kelvin, 2 to 5 Kelvin, I should say, of warming after including feedbacks from a doubling of CO2 or from all the anthropogenic warming we might cause this century. And the direct or reference climate sensitivity is 1.2 Kelvin before you allow for feedback. And so everything else to the right of that dark green box is feedback response. And they think, therefore, that feedback has a very big response. And here is why they thought that. This is the classic feedback amplifier block diagram. You start on the left with a base signal. That goes into the summative input node, P1. It goes up to the gain block G, then round following the arrows to the output node P2 with the output signal, then down to the feedback block with the feedback fraction in it, then back to the input node, and round and round and round infinitely. And nobody in climatology understands this diagram. It's too complicated. So my team have recently been working on simplifying this diagram, which goes back to Harold S. Black in 1926. And we came up with this, which gives you exactly the same output for the same inputs and the same feedback strength. And it's much simpler to understand. You simply add the base and gain signals before they even go into the feedback loop. On the left you see the feedback response. On the right, the output signal, and at the bottom there, the feedback block as before. That gives you exactly the same result. And when I first showed this to our professor of control theory, the theory of feedback from engineering physics, he said that must be some kind of a coincidence. He could not believe that the classic feedback loop could be represented as simply as this. But he has since confirmed that he agrees with this. So we can now put some figures on it for 1850. And this is exactly what I was told by Sir John Horton all those years ago. And that would give you, as you see at the bottom right there, about 4 Kelvin of equilibrium double CO2 sensitivity. And that is quite a lot. But here is how it should, here's what would happen if you carried on and actually went from 1850 to a doubling of CO2 after 1850. And you'll see that would still be 4 Kelvin of equilibrium double CO2 sensitivity, because they put in 1 Kelvin of direct or reference sensitivity. That means you get about 2 Kelvin of feedback response, 3 Kelvin is the final output, or maybe 4. That's the sort of thing that they expect. And you see that the feedback block is 0.7 either way, and that really doesn't change between 1850 and now. What they left out was the fact that the sun is shining. What they should have done is to put in, for 1850, the 260 Kelvin emission temperature that would prevail at the surface of the Earth if there were no greenhouse gases in the air at all. Then you add the direct warming by the pre-industrial non-condensing greenhouse gases, and then you send that round the loop, and you find that, therefore, your sensitivity goes down from 3 or 4 Celsius or Kelvin to just 1.3. And that makes quite a big difference to the numbers. We can now, again, double the CO2 compared with 1850, and you see it makes virtually no difference because the sunshine is so dominant in the calculation. So that means that if you then work backwards from the predictions they make of how much global warming we might cause, you then work out what the corrected feedback strength would be once you take account of the fact that the sun, like it or not, is shining. Then you see that it's between 0.14 and 0.27 watts per square meter per Kelvin of the direct temperature. And that is so small a number and so small an interval that we do not in any way have enough precision to measure and work out how much warming we will cause by using any kind of feedback analysis. And yet, the IPCC goes on and on talking about feedback analysis. Now, why did they not understand that they couldn't do what control theory normally does and leave out the base signal, which in this case is the sunshine? It's because in a traditional feedback circuit and for an electronic system or for a factory process controller, the feedback response is 1 or 2 orders of magnitude greater than the base signal. But in the climate, it's exactly the other way round. The base signal is 1 or 2 orders of magnitude greater than the feedback response. They didn't realize this. They thought you could use differential feedback analysis in the climate, and you can't. And IPCC in 2013 actually mentions the word feedback 1,100 times, but you can't use feedback analysis in doing climate prediction. So how can we predict global warming? Well, you can use the energy budget method. The equation there, which I won't go into in detail, you can do what's called a Monte Carlo simulation, which we've done here. This was 1 billion separate trials. And then you integrate the results and you get a fairly typical Gaussian distribution. And you'll see that once again, just as if we assumed that we were calculating on the basis of the 1850 feedback regime, you still get about 1.3 Kelvin as the mid-range estimate of double CO2 warming. We can also get the same result by an observational method, because in the IPCC's first assessment report in 1990, they predicted 0.3 Celsius per decade. Actually, only 0.14 Celsius has been seen. They predicted 3 Celsius per doubling of CO2, so we would predict 1.4 Celsius on the basis of the actual temperature change, about the same as the 1.3 we got before. And here you can see that it is indeed scenario A of the 4 emission scenarios in IPCC 1990 that is the one that is correct, because if we use the scenario B thing, you can see that the actual annual emissions have gone up by 50% compared with what the scenario B direction would have predicted. And also, just for fun, there's been no global warming for 8 years and 5 months. And you won't see that reported anywhere, except, of course, at Anthony Watts's wonderful blog. And so this is our third method, then. If we assume that the feedback regime stays the same today as it was in 1850, and that is the assumption that climatology itself makes, then, again, you would expect 1.3 Kelvin of equilibrium double CO2 sensitivity. So we've done that calculation by 3 separate methods and got the same answer, which is not much more than a third of the central estimate that they make. Now, there are 1 or 2 other interesting results that I would like to give you on behalf of others who couldn't be fitted into the program today. First, from Professor Art Vittorito, who has been a distinguished speaker here many times before. And he has been doing some research on whether subsea volcanism is making some contribution to global warming. And he says that the evidence for an intensification in the El Nino warming of the tropical Eastern Pacific after 1995 is to be found in the fact that the Western Pacific thermocline has deepened by 10 meters, as you can see from the data here. Deeper is actually higher in this slightly confusing graph, but that's how it goes. And here he says that if the thermohaline circulation warms from below, then you get exactly the pattern of warming around the Earth that we are actually getting. So again, there appears to be an interesting correlation there. And he says that polar amplification warms the Arctic faster, but El Nino amplification, that's the increase in El Nino activity in the tropical Eastern Pacific, then you can see that there's a significant correlation again there. And then he takes the global picture from 1979 to 2021, and he sets them aside by 2 years, and you get quite an interesting correlation. Again, now correlation is not necessarily causative, but these are several correlations, all of which seem to point to the same result. And what I would say to this is what you often see at the end of a paper when the author's looking for another grant. More research is called for. Now then, also, why can't wind and solar give us net zero? They're all saying we must go to net zero globally by 2050. But actually, we can't do that by relying chiefly upon wind and solar. And this is Douglas Pollock, who has also spoken here many times before, and he kindly got in touch and said, could I please convey very briefly his result to you? And this really is the end of the climate debate, as you can see, because the excess generation, if you put too many wind and solar systems on the grid, is equal to the nameplate capacity that you install of these weather-dependent sources, minus the mean demand on the grid every hour. And that's this is the equivalent in climatology of E equals mc squared. It's E equals N minus D. Nameplate capacity is the capacity to generate electricity by a weather-dependent source in ideal weather for that source. And so that equation means that if you put more wind and solar nameplate capacity on a grid than you should, then you will be throwing away the extra electricity, wasting the capital cost of the extra capacity that you've put on, and destabilizing the grid and very, very greatly increasing the cost. And he then had a look at various countries, and all those with red at the graph, those are the ones that have already overbuilt and are wasting their electricity and therefore paying enormous prices per watt or per gigawatt hour of electricity that they generate. This causes immense pain, Britain is losing all of its major heavily energy-dependent industries. Even little industries are going too, because we now have the most expensive electricity in the world, and we've only gone over that limit by 1/6. But that is enough completely to screw up the economics of the grid. And here you can see for the American grid in particular, that if you were to back up the wind and solar with all the fuels mix that you have now, a bit of coal, a bit of gas and so forth, then you make barely any change in the grid CO2 emissions. If you were to have gas backup only, then you would save sort of 10% of grid emissions, which is still only a very, very tiny fraction of the total US emissions. So you can see that even if you actually do install up to the limit in the United States, and you're only about halfway there yet, you still make virtually no difference either to the American or global CO2 emissions. Now that limit is actually a very important one, because it means that since typically you can't generate more than about 20 or 30% in most grids of your electricity from wind and solar without going over that limit and just throwing a lot of money away. Therefore, that is the biggest capacity you can install without continuing to increase your CO2 reductions. So if you get to that limit, anything more you put on after that will not reduce CO2, so it won't get you to net zero. So that result by Douglas Pollock is profound, and even though it looks naive, we've checked around the industry. Nobody knew that that limit existed. So here is something which Professor Simon Michaud of the Geologian Tutkimus Keskus, and that wonderful word Tutkimus Keskus, which I'm going to say again because I like it, Tutkimus Keskus, is the Finnish for geological survey. And I do love the Fenno-Scandic languages. They have these wonderful words. But now, what he's done, he spent several years looking at what techno-metals, the specialist metals, would you need if you actually wanted to get to net zero globally by the methods that have been outlined by those pushing this agenda by 2050. And if you take the total global 2019 production of each of just these 7 metals, which I've taken as a sample, then you'll see for copper, you'd need 180 years worth of the entire 2019 production of copper. Go down the list a bit further, germanium, greater than 29,000 years worth, vanadium, greater than 67,000 years worth. So that's kind of not going to work. In other words, there aren't enough metals even for the first 15-year generation of net zero energy infrastructure. And then, because all these things wear out after 15 years, you've got to throw away your electric buggy's battery and get another one. You've got to do the same with the windmills and replace them, and there's no way of recycling any of it. You've got to start again and find the same lot of minerals every 15 years. It's not like a coal-fired power station that lasts 70 or 80 years and is made of steel and concrete, of which there are massive supplies, and runs on coal, of which there's about 4,000 years of remaining supplies. So the next question then is, are we actually making any difference at all? Now this is the NOAA graph of the absolutely straight line increase in anthropogenic forcing throughout the last 30 years. And you can see that all those trillions spent has made no difference whatsoever. So let's pretend they might make a difference. How much global warming could we forestall? Well, there's been 0.4 Celsius of warming in the last 30 years, so we would be able to abate, if we all went in a straight line to net zero, 0.2 Celsius, and that is all, over the next 30 years. And so the infinitesimal effect of net zero emissions can be seen on this rather small print table. But if anybody wants copies of the slides, of course, I can let you have them. But what it means is that even if the whole world went to net zero, it's not going to make any discernible influence to the climate whatever. And if only the West does it, because the rest are exempt and they're not doing it, and China and Pakistan and India and Russia are all increasing their coal capacity, then you can see none of this is actually going to happen. And of course, if you target the West, as they are, and you exempt 70% of the planet, you're not going to get very far with your net zero ambitions. And why not? Because here is that increase in coal consumption already evident in China, India, and Pakistan, and that's before they've recently announced still further massive expansion. Now we're going to briefly count the cost of net zero. That is the IPCC's data that gives us the Celsius per units of forcing, and there's McKinsey's cost of going to global net zero. Just the capital cost is 275 trillion. You have to multiply that by 3 to take account of the OPEX cost as well. You're looking at 800 trillion. Here on the back of an envelope is how much money, how much global warming you could stop for $1 billion that you spend on making it go away. And the answer is 1/4 millionth of a Celsius degree, the worst value for money in the entire shoddy history of governmental economics. So why does all this matter? The answer is, first of all, that banks have banned lending for coal projects in third world countries, in Africa in particular. And that is racialism. There's no other word for it. It's racialism. Westerners live 80 years, Africans live 65 years. One large factor in that is they've hardly got any lights on at night, as our satellite shows here. And here's what's happening in Britain. Our steel companies are all pushing off and going somewhere else because they can't afford to put the furnaces on. Here's another one, steel. Corporate bankruptcies are at a record level because they can't afford the electricity. The interest rate on people's mortgages has tripled. The annual energy bill of a little post office and sweetie shop has gone from £7,000 last year to £56,000 this year, and they're all going bust. So here, at the end of it, I say this to you. You can see what complete nonsense this entire global warming rubbish is. And if those of you who are fortunate enough to see these presentations will lend your ear just for a moment, I will say this. We will not be silenced. We will continue to search for the truth. We will not fail or falter. We will get the message through to you, whether the mainstream or legacy media and their beastly controllers like it or not. The truth will be heard. God bless you all.